Right, Gemma, what's your second tip you've got for us?
Right, okay, so this one is doing maths is not the same as teaching maths.
Oh, I like it. Again, another good clickbait headline, that, Gemma. That's good for the viewing figures, that. Right, tell me a bit more about that.
Well, I started by trying to think whether or not this is actually a kind of non-maths specific type thing. Now, other people watching this of other subjects might just laugh me off the screen now, but I was thinking things like writing an essay is not the same as teaching children to write an essay.
Nice.
Or let's say in science, doing a scientific experiment is not the same as teaching children to do a scientific experiment.
Yeah, I like it, yeah.
And I think by thinking it in those ways, that helped me to think a bit more clearly about what I mean in a mathsy context, because I think I'm particularly guilty of this. Is when I started teaching, I had my favourite ways of doing things, my favourite methods, my favourite algorithms, and I naively thought that if I just showed pupils what these algorithms were and showed them what the steps were, that they would also then learn how to do these things. And obviously, years of experience have shown me that that's not necessarily the case. And there are pupils who will make sense of it as we go along, and that's great. But I think they are making sense of it despite my teaching, not because of my teaching. So what I'm particularly more interested in now is the pupils who don't make sense of things straight away, because that's where the challenge lies, and that's where it's beholden to me to make sure that I'm actually teaching something really well. So just because I show pupils the steps of solving an equation doesn't mean I've taught them to solve equations. It doesn't mean they understand what an equation is. It doesn't mean they understand what they're actually doing when they solve an equation. And as well, if I have different methods for different things, then it kind of presents maths to my pupils, however unintentionally, it presents it to them as this kind of hodgepodge of stuff that they've got to memorise. And if they're the kinds of pupils who struggle to make sense of it straight away and struggle to make the connections, that's where you get comments like, oh, I've just got to learn this bit now and it doesn't make sense to me, and oh, there's so much to memorise in maths, and those kinds of things. And that means I've not done my job as well as I could have done it.
This is interesting. So how do we kind of break that cycle, Jim? Because I've definitely fallen into this trap myself. What are some of the practical things that you yourself do to avoid falling into this trap?
There's the question. That's like the $1 million question, isn't it? So this is the one where I'll probably watch this back in a few years' time and go, you were talking absolute nonsense. But I think at the moment, it's about creating coherence. And coherence is the thing I'm really focused on at the moment. So for me, in the materials I'm designing, we have a core or a key number of representations, for instance, that we are weaving throughout the curriculum. And so I've mentioned them already, so I'll stick with the example of algebra tiles. So the area model in algebra tiles is built in from multiplying and looking at distributivity and those kinds of things with multiplying, then through to using them for simplifying expressions. Before that, comes positive and negative integers, and then weaving it on into area models with the tiles for expanding and factorising brackets. And then it goes all the way up through to things like completing the square, and into A level you could do it for polynomial division with a grid method, for instance. So for me, I'm not saying that is the best way to teach these things, but what I'm saying is if I have it as a constant or a coherent way that goes through everything, then every time I've got to teach a new concept, I'm just adding kind of an extra layer of complexity to something that my pupils are already familiar with. And that, I think, is more likely to make it have meaning for more pupils.
Yeah, that makes perfect sense. Does it mean, Gemma, that sometimes things may seem a little slower or less efficient to teach because you're trying to not just teach the concept but also get the kids familiar with, as you say algebra tiles? Like, solving equations is a classic, right? Because we all know real quick ways you can get kids to solve some amazing looking equations, but the problem is those methods don't scale, because as soon as you then get into quadratics, the whole world falls apart and you have to teach something else. So it feels to me like it's definitely the right thing to do, but teachers and the kids need to be aware that there might be, I've spoken about this in a previous Tips for Teachers video, this kind of valley of latent potential where initially there's a bit of a dip in short-term kind of performance and progress because you're trying to get to grips with something that's perhaps not as efficient a tool for doing that specific job, but we know that this tool has got these kind of long-term benefits. Does that make any kind of sense at all?
Absolutely, and I completely agree. And I would much rather spend 3 weeks on operations with directed numbers early on, in the knowledge that then everything we've embedded about that I can then apply to simplifying algebraic expressions, and it's just a tiny step up rather than being this whole new completely unusual thing. And all the pupils have then got to see is that, now we can do the same thing but with some unknown numbers, but actually everything else we're doing is exactly the same. And the gains then become quicker as you go on through.
That's lovely. A final question on this one, Jemma. Again, trying to play devil's advocate a little bit. Is there a danger that if we have these consistent representations and models, which I, hands up, I'm a big fan of, that we fall victim to having less variety in methods, and kids may have these lots of different approaches that they want to use, but we're actually saying, no, actually, we're going to use this one because we believe this is the best. Is there a conflict there? Is that a problem or not?
So, first of all, I think the kind of traditional situation that we found ourselves in, where we have lots of different methods for different things, I don't think it's too harsh to say it hasn't worked for a huge number of pupils. Because if we're saying that there's a massive number of pupils in this country who don't get above a grade 4 at GCSE, or don't even get above a grade 7 at GCSE. That's a huge number of kids who don't really understand a lot of maths after a long time studying it. So what we've done so far as a collective has been ineffective for too many pupils. So if you're saying that variety is important, then I think you've got to justify that this variety is good for the pupils who find things difficult. Now, I have no issue with saying, right, we're going to do these consistent methods because we are going to make sure that we have a coherence of a curriculum for our pupils in our school. But if you have pupils who really can't get their heads around this, I have no problem with teachers having other things, in their arsenal in order to help them explain things. But what I don't want is the default position to be everybody just throws whichever method they want at the pupils, because that's ultimately, I believe, going to make it too hard for too many pupils as they go through. And we all know that our pupils reach a ceiling, and I feel like at the moment, and this is based on quite a few years of experience doing this now, I feel like at the moment that fewer of our pupils will, or more of our pupils will kind of push the ceiling higher by taking a more consistent approach.
Yeah, it's really interesting. I've wrestled with this for a long time. So I assume you as well will be a big fan of Joe Morgan's Compendium of Mathematical Methods book. And I have a read through that and think, whoa, there's about 10 different methods for finding highest common factor and lowest common multiple that I've never even considered. And best case scenario, that's really good because you can say, all right, we're going to solve this problem this way, but you know what, there are 5 other different ways that we can use, and let's spot what's the same, what's different, what are the connections, and so on. And I think for some students that's really, really powerful because they start to see different connections and so on. But as you've spoke there, for other kids, it's really overwhelming, right, as well. And then maths becomes, right, what is the problem? So which one of those weird methods that I didn't really understand do I need to select to solve this problem? Whereas reducing the number of approaches by having these consistent, coherent models, I think for the majority of students is going to be the best thing. And then, as you say, there's always that opportunity, if they're seeming to grasp things, that then we can throw in these alternate methods, not just as a random thing, but to say what's the same, what's different, what's the connections, and so on. Does that make sense?
I absolutely love Joe's book, and I think it's brilliant for teachers because it helps them to see how all these methods are essentially doing the same thing.
Yes.
Because actually there's not 20 odd methods of adding numbers. There is one method of adding, and there's 20 different ways of presenting that method.
Good. Yes.
And so that's really helpful for teachers. But I think for us, looking at it with our knowledge and our understanding of adding is brilliant. If you're going to show lots of different methods to pupils who are still trying to cement their understanding of adding, I think that's cognitive overload there.
Yeah.
So I don't think it's helpful. But like you say, there will be pupils who can explore that. And I think everything we do in a classroom, we need to do very consciously and very carefully. So if I have a group of pupils who I would like to show a different method to, because I would like to use that to illuminate something to do with this concept that we've been learning about, and I know that that would help them to make more sense of something, brilliant. But I have to make sure that it's kind of passed that litmus test, if you like, before I do it.
Makes perfect sense. Fantastic.